Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Hi, my name is Rosalie Olmsted. I am WISA's Strategic Partner Coordinator, and it's a pleasure to have you all here today with WISA's strategic partner, Lockheed Martin. But before we get started and I pass it over to Ambrose and Madison, I'd like to give you a quick overview of the WISA's organization. We often go by our acronym, WISIS, because that is exactly what we are, a global cyber sisterhood. WISIS is a 501c3 nonprofit organization with a mission to recruit, retain, and advance women in cybersecurity. Our community is made up of over 10,000 members in 103 different countries. We have 72 professional affiliates and 311 student chapters around the world. We provide different initiatives and skills development programs, such as our book club, leadership series, vulnerability disclosure program, Create Your Leading Edge, the SANS Executive Cybersecurity Exercise, the mentorship program, and so much more. Additionally, all job openings from our strategic partners are also available on the Job Board Plus Plus. We owe all of our programs and initiatives to all of our strategic partners who fund us year-round, specifically our Tier 1 partners being 3M, Akamai, Amazon, Bloomberg, Carnegie Mellon University, Cisco, Ford, Google, Lockheed Martin, Optum, Sandia National Labs, SANS, and SentinelOne. Feel free to ask any questions throughout the webinar and drop them in the question box below. We will save some time at the end during the Q&A portion to answer all of those questions. If we run out of time, please feel free to connect with Madison and Ambrose on LinkedIn afterwards. And lastly, if you haven't done so already, please be sure to subscribe to the WISIS newsletter. You can find it on the upper right-hand corner at wisis.org, and it's the best place to stay up to date on all of our upcoming program launches, as well as our different webinars happening throughout the year. With that, I'm going to turn it over with Dr. Ambrose Kam with Lockheed Martin.
Great. Thank you so much for the great introduction, Rosalie. My name is Ambrose Kam. Also, along with me is Madison, and we'll be talking about some of our use cases in Lockheed Martin with respect to cyber AI. Next chart. Oh, okay. I can move my chart. Okay. Yeah. So a little bit of introduction about myself. So I'm a fellow for a few years now at Lockheed Martin. I'm also a chief scientist for the cyber tech domain area within Lockheed Martin. So Lockheed has 14 different tech domain areas, and cyber is one of them. So I help lead the cyber tech domain and really, look out for disruptive technologies that we can bring to the table so that we can better solve cyber problems for Lockheed and also our customers as well. I've been around with the industry, for a little bit now. I've been in the DoD industry since '95, so it's exactly 30 years. And for the last 21 years or so, I've been at Lockheed Martin. I'm here in Morristown, New Jersey, but I really work with a lot of people across Lockheed Martin as well. My expertise is kind of broad. I started off as a systems engineer, but I did some communications and networking, some time ago, and now I'm in cyber, as I said, and I really look out for interesting technologies like AI and certainly quantum, some of the blockchain stuff, and as well as 5G as well. I did quite a bit of work in these areas and got patents, and I got the chance to give lectures at top universities like MIT, Georgia Tech, and Penn State, and as well as Purdue as well. Also brought in interns from a lot of these service academies like West Point, Naval Academy, Coast Guard, so on and so forth. So I'm really excited to be here, and I'll turn the mic over to Madison and then have her give a little intro about herself.
Thank you, Ambrose. It's great to be here with you today. So my name is Madison Reynolds. So I've been with Lockheed Martin for 5 years now, doing mostly SCI work. I facilitate cybersecurity compliance efforts, as well as implement secure operating systems and ensure adherence to regulatory policies. I work with some proposal development aligned with government cybersecurity requirements. I do enjoy mentoring new cybersecurity engineers. I do hold a Bachelor of Science in Data Analytics and Cybersecurity, as well as an MBA specializing in information systems. I am part of the Lockheed Martin Recognized Technical Talent Program, as well as the Vice President for our Women in Cybersecurity Lockheed Martin affiliate. It's great to be here with you all, and I'm really looking forward to this presentation. So as you can see here, as defined by John McCarthy, the father of AI, artificial intelligence is the science and engineering of making intelligent machines, especially intelligent computer programs. In the context of cybersecurity, AI is important because it enables us to create more efficient and effective security solutions that can keep up with the increasing complexity of cyber threats. The key aspects of AI include the science of studying intelligence, the engineering of design and building intelligent machines, as well as the development of intelligent computer programs that can think and learn like humans. In cybersecurity, AI is used to automate security tasks, improve incident response, and enhance threat detection. As we move forward, we'll be discussing machine learning, which is a subset of AI that focuses on the development of algorithms and statistical models that enable machines to learn from data. Here is the AI timeline. So you can see here that in 1950 things kind of really began, as well as moving through those years. We see quite a bit of development and some really interesting movements forward, such as Alexa in 2014. A lot of those things that are now used in our day-to-day lives where we might not even realize that that is artificial intelligence. Here you can see the taxonomy of artificial intelligence. So starting at the top, artificial intelligence is going to be any technique that enables computers to mimic human intelligence using logic, decision trees, and then deep learning. Moving down over to machine learning, you can see that that is a subset of AI that includes the statistical techniques that enable machines to improve tasks with their experiences. And then moving further down, we'll see deep learning. This is a subset of machine learning that's composed of algorithms that permit software to train itself to perform tasks like speech and image recognition by exposing the multi-layered neural networks that include that vast amount of data. And then finally, reinforcement learning. This is going to be the subset of deep learning that gives machines the ability to simulate human behavior by learning from data that is simultaneously sequential, evaluative, and sampled. So what is machine learning? Machine learning is a subset of artificial intelligence, as we discussed, that involves the use of algorithms and statistical models, which enables machines to learn from data without being explicitly programmed. It's a way of training computers to make predictions, classify objects, make decisions based on patterns and relationships in data. So as you can see in this graphic here, you see the tiger, and then there are quite a few observations. So there's hidden layers involved in that, which create the output layer. So machine learning works by using neural networks, which are composed of layers of interconnected nodes or neurons. The input data is fed into the first layer, and then that flows throughout the network, with each layer applying a transformation to the data. The output layer then generates the final prediction or the decision, in this case whether to do nothing, to scream, to run, or to climb. The key to machine learning is that the computer is not explicitly programmed to make decisions. Instead, it learns from the data and adjusts its weights and biases to minimize the error between the predictions and the actual outcomes. This process is called training, and this is what allows machine learning models to improve over time and make accurate predictions. In the context of cybersecurity, machine learning can be used to detect anomalies, predict threats, classify malware. Overall, it is a powerful tool that can help us stay one step ahead and protect our systems and data from harm. So AI in cyber. So I kind of just alluded to some of those things, but in cybersecurity as a whole, AI protects against loss of classified information, specifically to any damage or threat to military systems. It autonomously can protect networks, computers, and data from unauthorized access, as well as develop some counterattacks and tools to tackle cyber threats. Within simulation and training, overall it will improve understanding and proficiency with combat systems and enhance military readiness and effectiveness through simulation-based training. For AI and data information processing, it can quickly process large volumes of data to obtain that quick, valuable information. It assists in identifying patterns and correlations, as well as enables predictive analysis and decision-making. The key benefits of this will be overall enhancing military effectiveness and readiness, improve cybersecurity and decision making, as well as support predictive analytics and situational awareness. Over to you, Ambrose.
Thanks, Madison. Yeah, so I think that's a great intro to AI machine learning. So I'm going to go down to the specifics about machine learning and a little bit more about reinforcement learning. So in general, there are three different types of machine learning. So you have supervised learning, unsupervised learning, and then reinforcement learning. Supervised learning will be like, you have some learning agents, you have to really train them, right? And so in the case of supervised learning, typically what you have is that you need to train the learning agents by giving them explicit information. So it will be like, you have large volumes of data, but then you also need to make sure that you label and structure the data as well so that you can train the learning agents as quickly as possible. So in the analogy of, say driving a car, right? So I have a daughter, so I have to teach her how to drive. So it would be like, the analogy would be like, I'm giving her explicit instructions. Hey, you make a left-hand turn here, you make a right-hand turn here. Don't run over the neighbors, mailboxes, or don't run over, the garbage bin, or don't hit the curb, that sort of thing. So you're giving that person explicit, instructions as far as how to do something or what to do in certain kind of situations. Unsupervised learning would be like that you basically learn, that you allow the learning agents to figure that out, themselves. So you don't really give any instructions at all. But the hope is that after many trials, these trial and error thing, the learning agents will actually figure out how to do something. So the analogy would be like, I sit in the car with my daughter, but I don't say anything. I just let her hit the curb. I let her hit the other cars. I let her like run the traffic light, that sort of thing. But hopefully over time she's going to learn how to drive the car herself, right? That may or may not work in some situations, but most likely that's not a efficient way of in terms of like spending time, or at least protecting my car, for example. So that brings me to my last one, which is reinforcement learning. So reinforcement learning would be like you're providing the learning agent some kind of reward, some kind of points or something like that, that you give them some instructions, but not too explicitly, but you would like to reward the learning agents when the learning agents are actually making the right decisions, or that they're doing something correctly. So you provide some kind of feedback loop. It's not as explicit as supervised learning, but it also prevents you, or at least in this case, that you don't need to have large volumes of labeled structured data. In some cases, especially in the case of cyber, when it's often very difficult to come up with large training data sets, I think that might be a viable solution. So that's what I'm been kind of focusing on lately. But we have also work that we have also used other type of machine learning methods as well. So I'm gonna move the chart. I think this is my chart here. So one of the first thing that I did, and this is kind of like going back almost 10 years ago, I didn't know too much about AI machine learning. I barely knew how to spell AI, right? But I wanted to use AI machine learning to maybe help with our cyber needs. And case in point, we as in the human cyber human operators, we are not really 24/7, 365, right? We got tired, we got sick of our job, we need to take breaks, we need to take some time off, and things like that. So, but then in the cyber domain, it's the cyber attackers are not going to wait for you, right? So I was just kind of curious if there's a better way of leveraging say AI machine learning, not necessarily to replace human operators. I don't think that you can replace humans anytime soon, at least in the case of cyber. But if there's a way that we can help alleviate our shortage of human, cyber operators, I think that would be very beneficial. So I actually went back to MIT. I was curious about what we can do with AI machine learning. So I met up with a team of students there, and we came up with a way to better leverage AI. And really, the idea is that we would like to use AI to provide cyber responses. So case in point, you're the one that's protecting your network or your system from hackers or from cyber attacks. But oftentimes it's very reactive, right? So your human operators may or may not, come up with the right responses when there's a cyber attack that might be happening, because there's so many different cyber attack vectors. We're talking about hundreds of thousands of different ways to attack your system. And so it's not easy to figure out what is the right courses of action there. And so instead of relying just on human operators, what I would like to do is to actually use some kind of automated cyber responses. And so so the students and I, we actually came up with this approach of using AI, really using shallow learning in this case here, to figure out what are the right courses of action, what are the right cyber responses might be given a set of attack vectors that might be going on there. And so that's really what we have done in this particular use case here. So the animation not animation, but the diagram on the right hand side, you see that there is different threat actors, and depending on how they choose to attack your system, there are a bunch of attack vectors that you need to be cognizant of. So rather than relying on human operators to figure out how to respond, we're using machine learning to actually come up with the right mitigation, essentially. And so we have demonstrated that at least we know how to use AI machine learning in terms of improving the reliability as well as the speed of the responses. And that's really part of cyber resiliency. Cyber resiliency has four different phases, right? One is anticipate, withstand, and then respond, and then to adapt. So those are the four main pillars within cyber resiliency. And so in this particular use case here, we are focusing more on the responses. And so that's what we have done in this use case here. Madison, do you want to talk about this other use case?
Yeah, so this other use case is going to be misinformation and disinformation. So I'm sure we've all heard those terms. So the fake news challenge involves labeling relationships between an article body, its headline, and which critical task in identifying if it's fake news. This challenge requires the development of advanced NLP techniques, which includes stance detection to analyze the article or the headline and determine its overall relationship. By doing this challenge, we improve our ability to detect fake news and reduce the spread of misinformation. The fake news challenge, it has significant implications for the future, which can help protect against the manipulation of public opinion or promote a more informed and critical thinking to the public. Stance detection is going to be the crucial technology in the fake news assessment. This enables us to determine whether the author of a piece of text is in favor or against a given target. The technology takes advantage of the natural language processing, the NLP, to overall analyze the text and detect the author's stance. To achieve this, stance detection requires word embedding and textual relationship analysis, which helps us understand the context and the sentiment of the text. The key technologies with this are, again, that natural language processing, NLP, which enables us, again, to analyze and understand the meaning of text. Word embedding and textual relationship analysis are essential components to capture the text and the sentiment, and that is critical for us to understand positional bias. Here you can see how the use case actually flows. So you can see that you would import the data, it would be pre-processed, then it would be converting the words to a numeric sequence, training that network to understand, and then classifying the data to understand. The development of stance detection and fake news challenge technologies can have significant implications for the future, as it helps us to promote a more informed and critical thinking public. By improving our ability to detect fake news, we can reduce the spread of misinformation and protect against any public opinion manipulation. These technologies can also be applied in other areas, such as social media or online content, to promote a safer and more trustworthy overall online environment. Over to you, Ambrose.
Great. So a few words about word embedding, right? I'm not sure if everybody understands what is word embedding. So computers themselves, they don't really understand the semantics of the words, right? They don't understand the meanings of the word. So what we did instead was that we basically trained the learning agents, or the computer in this case here, to have some underlying meanings of the word. So this word embedding technique is such a way that it basically converts English language, these words into different bins or buckets. And so you basically take words, and we have different vectors of numerical values. And so the idea is that if there are if words that are similar, they would kind of belong to the same bucket, if you will. So we often think of like 3D world, or I guess if you include time, that would be like four-dimensional. But in the case of word embedding, we are talking about many hundreds of these different vectors, if you will. So the advantage of that is that we can use this approach so that we can provide semantic meanings to the words as far as the computer is concerned. And then B would be to understand if these words or text, if we kind of string them together, if they have similar meanings. And so that this is a way that the learning agents is going to figure out the semantic meaning about the passage or about the article. And so in this case here, we leverage the long short-term memory, or LSTM, for this work here. And LSTM basically leverages the recurring neural network, or RNN. The idea is that this LSTM is really good for sequencing, and especially for words. In the case of word embedding or any kind of NLP processing, it's really good if you have sequence of words, and that's exactly how we are actually using this approach for. And then the diagram on the right is basically showing you that if we can group some of these words together, this is how you would kind of visually see it. And so the idea is that we have different articles, and then we can actually let the learning agents to actually go through the different articles. And then actually by using the word embedding approach, we can get the sentimental scoring and from the text of the main article, as well as from the text of the headers that themselves, or like the headers, or like the titles of the articles. And so the idea is that we can actually group them together and kind of compare between the actual body of the article versus the header. And so there are like 4 different responses that we allow the computer to choose. And it's really based on agree, disagree, discuss, or unrelated. So those are the 4 possible responses. And then we basically assign these ground truth value to actually train the convolutional neural network. And so that's basically how we are doing this, and how we actually leverage this CNN and also the word embedding. And I guess the other thing that I forgot to mention is that we basically leverage the BERT database. I don't know if you guys are familiar with it, but BERT stands for bidirectional encoder representation for transformers. So it's really a way to train the learning agents to recognize the semantic meaning of the words. And so in this case here, as what the diagram is showing you, we basically compare the headline versus the body of the text here. And then we divide into different blocks, and we kind of connect them. And so in this case here, we were using MATLAB. So the interface was really drag and drop, essentially. So that was fairly easy for us to put the CNN together in this particular use case there. And then like I said, we would actually train it with the BERT training data sets. And then once the learning agents have been trained, then we actually let them run through the articles from the fake news challenge. And so that's what we have done in that particular use case. The other use case is that with respect to cyber AI it was what I call the red versus blue kind of wargaming. And so in the case of cyber, we have what's called the red team. Essentially, what red team is really doing is that you as the cyber expert, you assume the role of the attacker, and then you try to attack a system that you would like to protect. And really, the whole idea is that you like to think like the attacker and understand what are the potential weaknesses in your security. And then by doing that kind of exercise, by doing this, then you as the person that would like to protect the system, you will have a better idea how to protect that system. So the analogy that I always use is that say you are the security guard of a bank, or a security officer of a bank, and you want to protect the bank robbers, and so you want to protect the assets in the bank. So you would like to think like, hey, if I was a bank robber, how would I attack the bank and actually steal the money? So maybe they would first do the reconnaissance. Maybe they would like to look at, say, how many cameras, security cameras that might have outside my bank, or maybe inside my bank, how they're being positioned, how quickly is the response time of the cops, for example, if there's an incident. What's the size of my safe? Where is it located within the building? Is it strong enough? Are they going to use C4 explosive? Are they going to have a locksmith to unlock it? Where do they where should I put the money, for example? So that kind of thing. So that really the whole idea is that we would like to understand how the attackers would attack our system, the same system that we would like to protect. And so that's what really this red versus blue kind of wargaming. And so instead of having human operators, for example, what we would like to do is to automate this whole process and actually use AI machine learning. Actually have two teams of AI agents to play against each other. So think about this as like a football game. You have an offensive side, you have a defensive side, and so the attacking side, or like the red side, is attacking your blue system, and then the blue side is trying to defend. Essentially, the analogy would be like in the football analogy. So you have a attacking side going to the offensive side, and then you have the defensive side trying to stop the other team from scoring, essentially. So this is a really useful process because in the past when we were doing these red teaming exercises, it takes us a long time, right? Because we need to figure out how the red team might be trying to attack your system, and you might need to look consider different cyber attack vectors. You need to perform the vulnerability assessment of your own system so that you can understand how these vulnerabilities or cyber weaknesses can be taken advantage of, and how they can be kind of exploited. And so, but instead, what we can do is that we can actually automate this quite a bit. And in our case, we have actually developed these kind of bins, if you will, these attack bins, if you will. The idea is that if you're on the offensive side, you would like to identify what are the possible attack vectors, and so you would look at, hey, this is the password hack. This is how I would do the email phishing attack. This is how I can steal somebody's credentials so that I can get a foothold on the door, so that I can send additional malware to these to the system. And then this is how I can take over say the router. This is how I intercept the messages. This is how I can perform the man in the middle attack, and so on and so forth. So they are like 100,000 of different ways of attacking a system. And so we actually categorize and actually collect these attack vectors and actually bucketize them. And so think of these as like Lego blocks that you can actually mix and match. And so that's exactly what we have done. And the same thing on the defensive side as well. There are specific defensive strategies. Like for example, the Midas defend framework. There are certain tactics, techniques, and procedures being listed there. And so we would like to be able to bucketize and actually put them in the bins, so that if certain attack vector is happening there, then we would know how to respond to these attack vectors. So long story short, we can actually make this whole architecture, this red versus blue wargaming, more of a kind of a Lego block, and actually allow both the offensive side, say the red team, to compose different attack vectors, and then at the same time, based on the attack vectors being recognized, the blue side can also compose their own cyber responses as well, so that these attack vectors can be mitigated or countered at least. And so that's been the whole idea. So instead of having human person doing that, human operators, we are using AI machine learning to help us. And so that's basically what we are trying to do here. So at the beginning, I mentioned about reinforcement learning. So this is how we would use it. So you have some kind of operating environment there. And really the whole environment is really composed of some of these cyber industry standards or frameworks. I mentioned about your attack framework and defend framework. There's also RMF or risk management framework. The 800 NIST 853B or NIST 800-160, which is the cyber resiliency techniques, and so on and so forth. And then on top of that, you also have National Vulnerability Database, NVD, and then you have KPAT, cyber attack pattern enumeration and classification. And so the idea is to kind of compose all of these together and categorize them, and actually build them and arrange them according to the relationship, so that we can actually provide feedback as the learning agent or agents to select certain kind of attack or maybe defend attack vectors, what will work and what won't work. And so there is a objective function which is the reward function that I told you about. And essentially, if a given attack vector selected by the learning agent is successful, then we would reward the learning agents for some points. If it's not successful, then we won't reward any points. And then so each episode will provide some feedback to the learning agents. And so after maybe thousands or maybe tens of thousands of these episodes, the idea is that the learning agents will is going to figure out how to attack this particular system based on the reward points that it collects over these episodes, and essentially that's the whole idea with reinforcement learning. And then so you have the offensive side, and then similarly you also have the defensive side as well. So the defensive agents will also try to figure out what are the defensive strategies, what are the TTPs from the defense framework that should be used to counter these attack vectors. So you constantly have this back and forth, your offense, defense kind of game there, if you will. And so that's basically how we can make the whole thing work. And so the interesting thing about this is that we can actually expose maybe new attack vectors that maybe human operators haven't thought of. Human operators, we typically have CTT or cyber tabletop exercises, and then we have penetration testing, we have cyber range. What I'm advocating here is not so much that we would like to replace all of those activities, but rather we can use AI machine learning to actually make the whole process go faster. So instead of looking for everything under the sky about these attack vectors, maybe we can only focus on this top 50 or top 60 of these attack vectors, and then you can take these ideas and actually try them out in the in a lab or inside the cyber range or something like that. So that's really the efficiency that we are looking for. And so that's the whole idea about this cyber AI wargaming work that we are doing here. And so we actually take that approach, and we have worked with different service academies, and a few years ago, probably 3 years ago now, we worked with a team of cadets from West Point, and so they actually came up with a military operation scenario, which is the one that you're looking at. It's more like we have some kind of asset, we have some kind of sensor, we have the shooter, so that they can be HIMARS or maybe helicopters launching air to ground missiles or something like that. Say Longbow, and then you have some kind of command and control node making decisions. And then the scenario goes like this. So you have the red side on the right hand side there, and then they would like to be able to stop the blue side from launching these missiles against their targets. And so they would like to launch some kind of cyber attacks. So this is unclassified, right? So this is just to test out the whole theory about how we can use cyber AI to perform this cyber wargaming that I'm kind of describing. And so we have basically demonstrated this with this capstone project with West Point. And so the students themselves, they came up with this kind of scenario on the left hand side. And what we have done, we have provided is a framework so that the students can actually take the scenario that you see on the left hand side and then translating them to the scenario on the right hand side. And I'm going to play a video and I'm going to come back to that. But let me. So what you saw in the video is that you have some kind of network. The idea is that the attack agent or agents will try to attack this network that you're seeing. We basically take the same network topology and then translating them into the playback file that you just saw there. And then the idea is that the attacker would like to compromise each one of these nodes and then ultimately trying to stop the blue side from launching the attack. And so the red side is trying to use cyber as a way to compromise this queue chain cycle, essentially. And so the concept is that the blue side, they also have defenders. So we have programmed the blue learning agents to basically defend this network. And so the idea is that the blue learning agents have come up with the right TTPs, defensive TTPs based on the defense framework, and they actually stop the red side from attacking certain scenarios. And in fact, in the video playback, and I can play it back again. But essentially, you can actually see that we actually push the attacker back and actually stop them from reaching their destination node. And I'm going to play back this scenario. And then at the bottom of the video there of the animation, you can actually see a table. So the red text going across the screen, those are the attack vectors, and then the stuff on in blue, that's the defensive mitigation. And so this is just a way to demonstrate that this concept actually works. So I'm going to play it back again. So that was a really quick kind of playback and really just demonstrate the whole concept. Obviously, in the real world, the cyber attack vectors are going to be a lot more complicated than what you just saw there. So that was a proof of concept that the students, have leveraged, or the cadets have leveraged our particular AI framework, and specifically the multi-agent reinforcement learning. And so we have actually since then we have actually extended that and actually to include a lot more data sources, including some of the exploits that we found on the unclassified side. And we have also actually take it to the high side as well on the classified. If there are some classified scenario, we can also perform something similar as well. But really the whole idea is to be able to improve the cyber resiliency of the network or on the system that we would like to protect. And so this is I mean, as I said, this is more of a proof of concept, but we have actually indeed deployed this to programs as well. And so we have had really good success with this approach there. I'm going to take it to the next chart, and I guess Madison.
Yeah, so overall, AI and machine learning have many use cases, applications in cyber, such as the anomaly detection, the predictive maintenance, threat hunting, and the incident response, as we discussed today. By leveraging AI and ML, we can extend our current cyber capabilities and improve our cyber resiliency. We can automate routine tasks, provide real-time analysis, as well as improve accuracy and effectiveness in our cybersecurity systems. Cyber is everywhere, and its importance cannot be overstated. It's a critical component for our national security and our defense systems, and its reach extends past our infrastructure and mission systems. Ultimately, these will help us stay ahead of emerging threats and vulnerabilities to enable us to respond quickly and effectively to all security incidents. That's all that we had today. We can move over to the Q&A now.
Okay, any questions from the audience?
We have a few, and actually I'm gonna jump us back to one of the slides because somebody had a specific question about case 3. And so Ambrose, I'm gonna say the question was, what does HST stand for? This case was slightly confusing to that individual. If you could maybe go over it again.
Yeah, sure. So HST stands for host. So those are the host nodes. So think of them as, hey, you have a network and then you have different nodes or different computers, if you will. RTR, that's the router. So essentially, and then you have the firewall there down at the bottom there, the FWL, and then you have the attacker node. So in this case, obviously we assume that the attacker, they already have a foothold in the door and is trying to attack certain nodes or certain host node, a certain system there, maybe to steal some information or stop some of these nodes from operating. And so that's really the whole idea, is that we would like to assume some kind of network topology, and then assume that there is the presence of the attacker, and then you would like to kind of play out this red versus blue kind of war gaming, so that you understand how your system might be attacked, and at the same time you can actually try out different defensive strategy as well. So you can use this as a way to answer these what if questions, or hey, what if I deploy some kind of antivirus, or maybe I implement some kind of zero trust architecture. Can I stop maybe 50% of the attacks, something like that. So you can actually quantitatively, help you make a better decision as far as where to make your investment. For example, what is my biggest bang for my buck, so to speak. And so that's another potential potential use case, if you will, for this approach. Yeah.
Thank you so much for expanding on that. I'm sure that really helped. And if that viewer has any further questions, please feel free to drop them in the question box. We can come back to it. And then a next question, I believe this was Madison's slide. There, we're curious, where do large language models fall in the taxonomy?
Yeah, so thank you for that question. So LLMs are part of the machine learning module, which is a subset of overall narrow AI. They're designed to perform the specific tasks such as a language processing, text generation, or conversational dialogue, and they're not really capable of general intelligence or human-like reasoning.
Awesome. Thank you so much for expanding on that. I'm going to go back to the question slide. I believe that was the last one specifically about slides variation. Next question is, AI can be incredibly powerful and helpful, but how do we ensure it's being used for good and not devious purposes? Specifically, how can we best protect ourselves, our personal information, our companies from being compromised? For instance, many are saying that I shouldn't personalize my voicemail greeting as my voice can be recorded and used to imitate me for voice recognition systems.
Yeah, I guess I can take a stab at it. There's a I guess there's a response at the personal level. There's also a response at the enterprise level. But I'll touch on the enterprise level first, right? Because when we deploy AI systems or AI models out there, they themselves they need protection as well, right? So you have seen us how we can potentially leverage cyber AI from the resiliency or at least from the defensive standpoint. But obviously there are cyber actors out there, state sponsor or maybe even individual hacktivists. They would like to do something to your system or to the enterprise network. So we need to make sure there is explainability. I think that's the first thing. When we develop these AI systems, we would like to protect these systems just like any other platforms out there. We develop F-35, we develop Aegis. We would treat those AI systems in the similar way that we are protecting our military hardware, for example. And as such, we need to better understand what are their vulnerabilities. And so me and my team, we have been doing quite a bit of vulnerability assessment lately, and really try to come up with what are the possible exploits that might be out there. And so we need to look at the hardware software list, SBOM list, HBOM list, and then we also need to go through security scans or the software scans, asset scans, the statistical analysis, as well as some of the software scans that can help us pinpoint where the vulnerabilities might be. And then to go along with that, we a lot of times we actually invite third-party vendors to actually come and actually take us and evaluate our systems as well. So we wanted to make sure that there is robustness and trustworthiness built in, and that's really part of the validation process that we have. And then explainability is a huge part of it, right? So we need to make sure that we are not treating AI systems as just simple black boxes, right? We cannot just say that, hey, just because it comes out from the model, we're gonna treat them as gods then, and those are not necessarily gospels, so to speak, right? Just because the AI system provides you with an answer, you better make sure that you also have somebody within your pipeline to check to make sure that it's actually responding or is actually doing something that you would expect it to do. And so that's really important. It goes back to our to the old saying, right? Garbage in, garbage out. So we need to make sure that we understand the robustness and that there is explainability built in, and it also doesn't hurt to have a third party reviewer to actually look at what you have done. And so that's basically what we've been doing, and we also follow a lot of these NIST guidelines as well. So NIST stands for National Institute for Standards and Technologies, and so they publish several guidelines as well as the not just about the ethics, but also the development process of AI models. And think of AI models as another form of software, right? And in fact they are software. So you would need to have a certain type of rigor, if you will, when you're going through the CI/CD process, how you can identify vulnerabilities. NIST, they also have what's called the Atlas framework, which is similar to the attack framework, but for AI systems. And so we are trying to integrate that into our bigger cyber graph, cyber knowledge graph, so that when we perform our vulnerability assessment, we can actually apply the same methodology to the AI models as well. And so that's what I would say at the enterprise level. At the personal level, I don't know. I mean, I don't know if you can completely avoid using AI. I mean, we started using AI, I mean, every day now, right? Whether it is when you're interfacing with your banks or when you are, trying to place an order. I mean, AI is basically everywhere. I'm not sure if you can completely avoid the use or the threat of AI. We just need to be careful and kind of limit your own exposure. I think that's what I would, that's what I would recommend. And yeah, use VPN and exercise cyber hygiene as much as possible, obviously. So.
Thank you for that, Madison. Did you want to weigh in on that question at all?
No, I think Ambrose covered it very well. Thank you.
I do as well. I just wanted to make sure if you had anything to add. Next question is specifically, are there any research articles or white papers that you have published or would be most relevant to your talk today? Perhaps key influential articles from others. There's an abundance of research out there, and this individual is asking for work and what would be the most relevant and what you're interested in the intersection of cyber and AI.
Yeah, I think that's a great question. In terms of white paper, I've done some, I've written some internal white paper. The other white paper that I'm actually working on right now is really the use of attack graph and how we can use AI machine learning to expand this attack graph concept. It's kind of similar to the video that you saw there, but instead we would like to apply it to apply that whole concept, that same methodology. To a specific instance. Maybe we would like to apply that in a critical infrastructure, for example. So we would like to be able to protect maybe power grid. I mean that's a no-brainer right now, because that's our power grid is very vulnerable to attack. I mean, it's what you have seen back in 2015, 2016, back in Ukraine, for example. So we do need to exercise caution and make sure that we understand some of the potential exploits and vulnerabilities associated with some of these these infrastructure. Late last year, I think I did publish some work through IEEE, for example, and so I was focusing more on the use of cyber AI for 5G purposes. And in that case here, instead of just using attack framework and defense framework, I actually incorporated MITRE's fight framework, which is the equivalent of attack, but for the 5G purposes. And so I've done some work in that area. Feel free to Google me. I also have some lectures that people post on just on the internet from Georgia Tech. So that I think there's at least a couple of them. Yeah, so I do think that there's a lot of good use case cyber AI applications. I think that in addition to the ones that I've mentioned here, we are also looking at the use of quantum computers. And so in some instances, in some particular use cases, quantum computers can speed up the training process. And what I found that is true, that over the years, is that the training process is sometimes the Achilles heel, right? Because it takes a long time to get the data, and then B, it takes a long time to actually get the learning agents trained up for specific purposes. It kind of goes back to somebody asked me about the robustness of AI, right? We need to make sure that there's no data poisoning or any type of attacks like that, or any kind of biases. And so that's something that will be ongoing. I think there's a lot of work that's coming out in that area in terms of vulnerability assessment and actually ensuring that the AI models themselves are robust enough for your given use case. And then, like I said, the use of quantum, I think that's an interesting technology that we need to keep an eye on. I think that's going to be a disruptive technology. I don't think that quantum computers are going to replace our binary, classical computer like what we are using today with Intel processor or x86. But I do think that for a very long time, I think that you see at least the simultaneous existence of quantum computers and also classical, what we typically call classical binary computers. So that's what I would say.
Thank you, Ambrose. And how would you factor in media bias? Because you touched on that in your answer to the last question. Is there a specific way that you can factor in the media bias going forward?
Yeah, that's an interesting question. It's not an easy answer. I mean, when we first started with that fake news, that example, that was done probably 7 or 8 years ago. Because I was curious about how we can use the sentimental scoring and in terms of identify fake news, and so that's one area. And obviously, we are bombarded with social media these days. Whether it's Facebook of the world or X or whatever, right? So there's a lot of real articles and not so real stories, and so it's not easy and quite, frankly, you don't really, you as an individual, you probably don't have the time to actually make sure that all the stories or all the news that you got are actually real. But so that's another reason why we need to be cognizant and why we need to cross-reference and actually look at this a couple of articles that might be reporting on the same story to see if there to see if there's like consistency there. Other than that, it's pretty hard to actually verify like every piece of articles that you have or that you come across.
Yeah, agreed. It's we are being bombarded lately. And how can cybersecurity? Oh yes, Madison, please.
I was going to add on that, and I do see that Maria included a similar question kind of in the chat with that, with using AI and how to use in those built-in cyber tools while also being aware of it. And I think that just making sure that we're verifying data quality and accuracy, checking for those biases, and not being over resilient on AI, which is something that Ambrose did touch on. Again, it is everywhere, but it's something that we still need to be the human in the loop, looking for those things, making sure that we're having that transparency, making sure everything is relevant and accurate, as well as ensuring that it is a seamless integration with those systems while also understanding what's going on with it.
Thank you, Madison, for adding in. And I'm glad you looped in that other question, because there's just so many great ones that I wanted to ensure we're trying to hit on all of them at once. How can cybersecurity practitioners prepare for the shift towards AI?
I think yeah, go ahead if you want to jump in, Madison.
Yeah, I was going to say that the most important thing is just familiarizing yourself with AI, as it's not going anywhere. There are a lot of machine learning concepts, and it's important to be aware of those and how to implement them, stay informed. Something that we do recommend is finding a news source that has some of those current things that are going on within the industry, and that will be very helpful in understanding how to use it, how to stay on top of it. Make sure that you're staying aware of any threats. There's a lot of AI-generated malware, phishing attacks, and social engineering tactics that are going on. And again, just focus on human-centered security. As AI might take over some routine tasks, cybersecurity practitioners should just stay focused on those high-touch, human-centered security tasks that do require some of that creativity, that empathy, that critical thinking, all of that. Now over to you, Ambrose.
Yeah, I guess the only other thing that I would like to add would be if you're in a position to verify and validate these AI models, I think that would be useful. At least in the line of work that I do, we often have a second model to do the same thing, and I'm kind of curious to see if it would produce the same answer or recommend a similar set of course of actions there. So at times, if it's possible, do some more validation. Again, just like any other new technologies, there's a lot of benefits, but there's also a lot of pitfalls to new technologies, and so we're really at the cusp of something really disruptive. And so we have seen that in many industries, and I think in our industry, DoD, I think that's going to be more and more important. I wouldn't. I think that in the next big war that we fight, I think it's really about how we incorporate the use of AI. It kind of goes back to the third offset strategy. I don't know if you guys might be familiar with that. It's not so much about hey who has the bigger guns or who has the faster jet or whatever. I think it's how can we better leverage some of these commercial off-the-shelf technologies like AI, for example, and how we can better utilize them. And whoever has the better robustness or the best use of AI will come out on top, and that's my opinion there. So.
Well, thank you both for this incredible webinar and incredibly enlightening. We are sadly at time, and I know we still have a lot of questions, so I will just say and add, if you want to continue the conversation or ask these questions to Madison or Ambrose, please feel free to connect with them on LinkedIn, and they will gladly continue that conversation. But I just wanted to say on the WESIS side, thank you both for taking time out of your day and presenting with our community. This has been such an incredible webinar, and I am disappointed that we can't continue on the conversation. And thank you, viewers, for joining us. It's been a pleasure, and I hope everyone has a great rest of your day.
Thank you, everyone.
Thank you so much.